Hi, ladies. Happy Friday. Sorry, it's Friday afternoon. We've already had maths today. Apologies again for being late, but hopefully this awesome video will make up for it. It's also interesting to see a lot of you found the other video I created the other day, and halfway through it, I realized that I kind of stuffed up a few quadratics. They didn't turn out too nice doing them by hand, and I ended up doing them by calculator. Please, you can watch it if you like, but I would rather you probably watch this video instead because the other one, when things get too hard, it's probably going to further complicate things then, and you're going to miss out on things that you should actually be learning because you're going to freak out and think, oh my gosh, I got to do this. Trust me, I will never assess you on a quadratic that is too hard to do by hand. So if you had your calculator, that's fine, but remember this skills test is without a calculator. So I will only give you quadratics that you can do quite easily by hand. All right, let's move on. Otherwise, I'll talk forever. So you got this today. This was actually going to be your original test, but your new test has changed slightly. I have added 15 multiple choice questions and there's a few short answer. So the short answer component will be similar to this. The 15 multiple choice questions will be similar to the multiple choice questions you've done on past tests. Now those quizzes, I know they're multiple choice questions and they're a little bit harder, so not as challenging as those. So if you go back to the past tests that you've done, you should be fine. Okay, let's move on. So, question 1. A quadratic has the following equation: y equals x plus 2, x minus 2. So first of all, use this equation to complete the following table. And I had a few questions today with this one, and people, it just threw them. Okay, this basically just means, what does y equal when x equals negative 2? And I've just realized I don't have my desk scribble up, so let me just quickly do that. So what you do is you substitute in your negative 2 into this equation. So if I was to do that here, y equals, so remember x equals negative 2. So x equals negative 2. What does y equal? So we've got negative 2 plus 2, negative 2 minus 2. So negative 2 plus 2 is 0 times negative 4 gives you 0. When x equals 0, okay, so again, we're putting zeros in here. I might just rub it out. Okay, so this time we're doing 0. Oops. So I'm trying to be quick, and I think I right-clicked instead. Okay, there we go. All right, so this time we're letting x equal 0. So let's just put 0 in here. Okay, so 0 plus 2 is 2, and 0 minus 2 is minus 2, so we have negative 4. And then when you think about it, if we were to put 2 in here, we're actually going to get 0. So I'll just quickly do that. The reason I gave you this table is because you can see here and here we have our x-intercepts. So remember, your x-intercepts are when y equals 0, and it worked out that way because I did it on purpose, okay? Don't think it's a coincidence. I purposely did it like that. And here you have your y-intercept. So I just did that to help you graph your parabola. Now on your actual test, I'm not putting those tables on because it has to be a lot shorter and we need to save time. So let's graph this one. Okay, so I can't see the equation anymore, so let's just write it over here. X minus 2. Okay, so we had a, x-intercepts at negative 2 and 2. Okay, so we can plot them on. I do have grid lines on here, but I don't care if, for now, I mean, you should be spacing things equally, but you don't have to put your negative 2 here and your 2 here. Okay, it doesn't matter where along this line you do it. And I'm just going to put negative 4 here because I can, okay? So when you're graphing, it doesn't, there's no numbers on here, so it doesn't matter what your scale is. All right, so let's join the dots. So there's one side, and then we'll just go, oh, I think that's the best one I've ever drawn. And there you go. There's our parabola. Let's clear that, move on. What's the next question? Oh, I didn't label. So your x-intercepts, you should be labeling them. I did put the so I did put do it, yeah. So your x-intercepts were at -2 and 2, the y-intercept was at -4, and your turning point was actually at 0, -4. So that's the only one I didn't put on, was the turning point. It's a hard thing when you can't see everything, and I actually don't have a copy of this next to me. All right, question 2. So this time we have a quadratic in turning point form. Okay, so hopefully you're familiar with the different forms. The previous one was factorized form. This one's turning point form. So again, use this equation to complete the following table. So we're just substituting in here. So let's do 0 first of all. So, you know, when you're doing a test, you don't need to put everything down. So I would just quickly do this. -5 squared is 25. Don't forget, negative squared gives you a positive -1, so it's 24. What's the next one? 4. So 4 minus 5 squared minus 1. -1 squared, 1. 1 minus 1 is 0. And then the last one, 6 minus 5 squared minus 1. 6 minus 5 squared is 1. 1 squared is 1. 1 minus 1 is 0. Beautiful. So I have my x-intercepts are here, 4 and 6, and my y-intercept is there at 24. Okay, so let's see if I can remember that. I don't think I can. Oh, and now I have to draw it. Okay, so 24, 4, 6. 24. Okay. Okay, so 24, so our y-intercept is at 0, 24, and our x-intercepts were at 4 and 6, weren't they? Oh, look at me rushing. What am I doing? Should be 0, sorry, and 6. Okay, so the problem is we have this very high number here, this 24. It doesn't matter because your scale, all we need to do is put that 24. So it doesn't really matter where you put that 24. Let's just put it there. And the 4 and the 6, if I went up by, oh, I kind of want to put my 4 and my 6 there, but that's not going to make it very even. So if I went 4 here, so that means 2, 4. So my, oh, it's not going to look very nice, is it? Hold on. I'm going to go up by 2. So that would be 4 and that would be 6. So 2, 4, 6. Okay, so my graph's going to go over here. The other thing I didn't do before was my turning point. So remember, your turning point is halfway between these 2 points, and I can easily see that it's going to be 5. And I've forgotten the equation. Oh, now I have to scroll up. Just bear with me. So -1. Beautiful. Okay, so when you substitute that x equals 5 back into your equation, you get y equals -1. So that's going to be, oh, this is where you're, no, let's just do it here. So that's 5, -1. And it's a pretty horrible graph, but anyway. So let's join the dots. So I'm going to first of all go through here. Yeah, I probably, thinking about it now, I probably wouldn't do it this way again because, yeah, didn't turn out too nicely. But you can see the main points, and that's the main thing. So if you can see your y-intercept, your x-intercepts, and your turning point, or if I can see it when I'm marking it, I will still give you the points. It doesn't matter if your parabola looks as crappy as mine, okay? As long as you have those key points in, that's all I worry about. Okie dokie, let's move on to question number 3. So a quadratic has the following equation. Use this equation to determine the x-intercepts. So this one here, even though it's in expanded form, I can't actually factorize it. Okay, so when I say factorize it, I mean finding two numbers when multiplied give you -4 and when added give you -8. Okay, I can't do that. So I either have to put it into turning point form or use the quadratic equation. Now I'm a huge fan of the quadratic equation, so that's what I'm going to use. So remember your quadratic equation, first of all, identify A, B, and C. So remember, A is your coefficient of x squared, B is your coefficient of x, and C is your constant. And I know I'm going to run out of room here. And I haven't checked whether these are nice. Actually, did I check? I can't remember. Okay, so negative b, so we're going to have 8 plus or minus the square root of b squared, which is 64, minus 4ac, now there's a minus there, minus 4 times 16, okay, over 2a. I'm doing a lot of this in my head, but you obviously will have already done it and you're just watching this to check your answers. So 8 plus or minus, what's it, 80? That's not too bad. Over 2. Now the square root of 80, I know 4, no, that's not the highest. What is the highest square? 16? Does 16 go into 80? I'm going to just cheat for a second. I think 16 does go into 80. Yeah, 5 times 16. Okay. All right, I'm just going to do, I knew 4 did, but then I also knew that there was a higher number. Okay, so let's just quickly do the simplification over here. So hopefully you remember back to semester 1 when you did surds. So square root of 80 is the same as square root of 16 times 5, which becomes 4 root 5. 8 plus or minus. Oh, aren't you glad I didn't end up giving you this on your test? Okay, so now I'm just going to separate. Oh, well, I can divide everything through by 2. So we have 4 plus or minus 2 root 5. Now, square root of 5, this is where it's not probably nice, is approximately just over 2. Okay, so I know the square root of 4 is 2, so the square root of 5 is going to be just above 2. So your values of x is going to be 4 plus, let's say, 2 times, I'm just going to say the square root of 5 is 2 point something. So we're going to have 2 times 2 point something is going to be 4 point something. And then we're going to have 4 minus 4 something. Okay, so it just helps us when we actually do our graphing to see what it's supposed to look like. All right, so we're around just above 8 and just below 0. Okay, so this is going to be hard because I'm going to have to get rid of everything. Just above 8, just below 0. Okay. Oh, I'm going to skip all that just because I'm going to have to graph it later anyway. And let's say 8 is up here. Okay, so what did we actually have? I can't remember. What was it? 4 plus 2 root 5 and 4 minus, that's probably not at the best spot, minus 2 root 5. I should just check whether that's right. Yeah, I'm pretty sure it's right. Okay, let's scroll up. Okay, so our y-intercept is -4. That's nice and easy. -4. So let's just put it somewhere down here. And our turning point, this is really horrible doing it this way, isn't it? It'd be nice if I had the answers already on there. All right, your turning point is halfway between your x-intercepts, but also remember your turning point, we can just do -b over 2a, so it's going to be 8 over 2, which is 4. And substitute that back in to get the y, so we're going to have 16 minus 32. That's at 20, negative 20. Just check. Negative 36, yeah, negative 20. So 4, negative 20. Let's just go straight down here. Line it up. Come on. Okay, oh, this is where it's going to go off my graph. Let's just say negative 20 is down here. Okay, so that is for negative 20. Clearly my scale is not the best, but you get the gist of it. Okay, so we need to go through our first x-intercept, go down to our turning point, go up through our y-intercept, don't forget, whoops, sorry, and there we go. So it's not too bad. Okay, so I can see my x-intercepts there, 4 minus 2 root 4, 5, 4 plus 2 root 5, y-intercept of negative 4 and my turning point down there at 4, negative 20. Okay, let's keep scrolling. What are we at? 16 minutes, sorry. Okay, a parabola has a turning point at 3, negative 6 and 2 x-intercepts at negative 3 and 4. Determine the equation of the parabola. Okay, so for this one, I would put it in this form. So x plus 3, x minus 4. Okay, so in factorized form, because I know these x-intercepts, so I can put it in this form. I just don't know what a is, so I can substitute these values in. So if y is negative 6, 3 plus 3, 3 minus 4, and I just solve for a. So a times 3 plus 6, 3 is 6 times, negative 12, sorry. 6 times negative 12, so that's 72, negative 72a, and that means a is equal to 112. Sorry. No, not 112. Is it 112? Hold on, I need to pause. Okay, sorry, I just had to make sure it was right. I don't know why I would have given you something with 1/12, but anyway, x plus 3, x minus 4. So let's graph that. I'm just trying to think, is that actually going to, is that right? Actually, I've made a mistake because you can't have, hold on, I'm just thinking aloud here, negative 3 plus 4. Yeah, this question, I think my turning point is incorrect because your x coordinate of your turning point should be halfway between these two. So negative 3 and 4, your x coordinate should be at, negative 3 plus 4 divided by 2. Yeah, so that's wrong. That should be a half. Okay, we might leave that one for now. Actually, what I'll do is I'll just wipe it and just change these values slightly, and I'm terribly sorry to do that to you. Just yeah. Okay, so let's change the turning point. And I don't want to make it a half because a half's just horrible. So what if we change this one to, I do want to make it 1. Let's change it to, how about negative 8? Actually, what we could do, yeah, let's make it negative 8. No, let's make it negative 10. Because then we will get the turning point at 3. So negative 10. Oh no, that'd be at negative 3. Okay, sorry. This is where sometimes you should not make things up. I do want to give you a question, so I might pause and just think of some numbers that'll work. Okie dokie, let's try these values. Just before I move on, if you're thinking, how could I still get an equation? So this point here can still be a point on the graph, but the equation I had actually didn't have it as a turning point. Okay, so if I and I actually graphed it just to see. So here's the equation we have, and you can see that clearly the turning point is not at 3. So there is the point 3, 6 on this graph, or 3, -6 on this graph. It's just not, actually was it -6? Oh, what have I done wrong? Anyway, doesn't matter. Let's move on. So I've changed this to -3. So that is halfway between our 2x intercepts, and -6 should hopefully be a nice number to work with. Okay, let's start again. Y equals, oops, let's not forget the a, x plus 10, x minus 4. Oh, I just realized there's another one. You could probably use the turning point form doing this as well. All right, so we've done that. Let's substitute in -6, -3 plus 10, and -3 minus 4. Oh, we're not going to get a nice. -6 equals a. -3 plus 10 is 7, and -3 minus 4 is -7. Just make sure we're right. All good. Okay, I can get rid of my negatives on both sides, so I've got 49a. So a, sorry, is over 6 over 49, and that does not simplify at all. If you wanted to put it into turning point form, you can do y equals a x minus h, so x plus 3 minus 6, and then just substitute in one of these points. I'd do 4, 0, just a bit nicer. So a 4 plus 3 is 7, 6. So, sorry, 7a minus 6. So a, what have I done wrong? I've got to put my squared on, that's why. So that should be 49. So 6 over 49. Okay, so either way you could get your equation. So you could have it in factorized form or in turning point form. Just remember you need to put this value back in for a. Okay, so you could either do it there or do it here. Okay, so when we're graphing, I hope you're still with me. So let's just plot those points. So -10 and 4. Okay, so -10 and 4. So I might I go up by 5, so -10 and 4, and the other one was -3, wasn't it? -3 and -6. So there's our turning point there. So it doesn't matter about that a, even though it's horrible, it doesn't really make drawing it difficult. It's just a pain in the butt having those numbers. So was it -3, -6? Okay, so there's your parabola. All right, that worked out a bit nicer, didn't it? Aren't you glad I didn't give you that one for the test? Okay, let's make sure this one works. All right, a parabola passes through the origin, has a turning point at 2, 4. Determine the parabola. Okay, now origin. So many kids get thrown off by this, and I always try to put it in, not to throw you off, but to make you realize that the origin is the point 0, 0. So your equation is going to be, well, hold on, let's go back here. It's just going to have an x by itself. So an x plus 0 is basically one of your factors. So if we're doing, and I much prefer turning point form, and because we've got the turning point here, we can't actually use the factor form. So what have we got? Ax, and then what's our turning point? 2, 4. So -2 squared plus 4. Oh, we don't. We need. Oh, so we don't have a value of a. Let's assume a is just 1. Okay, so let's just say there's no dilation factor. So we have this as an equation. So when we're graphing that, we've got a turning point at 2, 4. And we're going through the origin. Let's go down here. So there's the origin. Turning point at 2, 4. So let's just say 2, 4 is here. Okay, so we're just going up by 2, 4. So it's going to be a negative parabola. So actually, no, it doesn't have to be. Let's just say, oh my gosh. Okay, no. This one's going to be positive. Now, because, actually, no, it has to be negative. So that means, oh, I'm terribly sorry. We have to have a negative out the front of our equation. Oh, I got rid of the equation. Okay. I can't remember what the equation was. But if we're drawing that, so we know it goes through our origin, there's our turning point. So your other x-intercept, remember it because your parabola is symmetrical, has to be here at 4, 0. Okay, so if you think of your x-coordinates, your turning point is halfway between your x-intercepts. So if this is the halfway point, the end point has to be here. So there's your parabola. Okay, oh, actually, now I realize what I did. So, yeah, I realize why I did this question, because I wanted you to see that other x-intercept. So that other x-intercept was 4, 0. And our turning point there is at 2, 4. So now we can get our equation. That's what I wanted to do. Sorry. Okay, what did we have? X plus, minus 2 squared plus 4. And now we can substitute in 4, 0. So we have 0 equals 4a. 4 minus 2 is 2. So 4 to 8a. So that's, yeah, so a is going to be negative a half. There we go. So that's how you get your equation. I knew there was enough information there when I did it. So it just required you to find this extra point, and it would have helped if you drew it first. So your equation is y equals negative a half x minus 2 squared plus 4. And this half you can write it as all over 2 if you prefer. It doesn't really matter. Okay, are we done yet? Are there any more questions? I'm pretty sure there's okay, question 6. Sorry. Use the following graph to answer the questions below. All right, let's just see what the question is. Is it just finding the equation? Okay, let's just find the equation, because the other things we can clearly see. So your y-intercept there is at 18. Your x-intercept is at 3, 0, and your turning point is also at 3, 0. So finding the equation of this graph. Now, we got a turning point at 3, 0. So I'm going to just put that into turning point equation. Plus 0, we don't need to put that in. Okay, so we just need to find a. We can put any point in, but I can clearly see it goes through y equals 18, so I can just do that. So 18, negative 3 squared is 9, 9a. So again, a is equal to a half. So your equation is going to be y equals a half x minus 3 squared. Okay, nice easy one. But yeah, with your graphs, if you're given a graph, just write down what information you do know. If you have the turning point, I find the turning point form a lot easier to work with. But if you've got 2 x-intercepts and you don't know what your turning point is, you can use the factorized form as well. All right, I'm going to keep scrolling because I think this might be the last question. Fabulous. I'm sorry to have a bit of a mistake. What question was it? I think it was the only one. This one here, question 4. Terribly sorry. but I'm glad it didn't go through to the final test. Your actual test on Tuesday will be perfect. But also this test, if it was given to you, would have been checked before you did it. So don't think I would have gone ahead and given you a dud test. I would have made sure it was right. Okay, girls, have an awesome weekend, or I hope you're having an awesome weekend. Saturday's going to be pretty crappy, but I think Sunday's going to be wonderful. So perhaps stay inside on Saturday and do your study and enjoy the sunshine on Sunday. Bye-bye.